Hey Valley Middle. I'm here today to work with you on your grade 5 MCA item sampler. A number of you struggled with it, so I'm just going to run through the problems and work them for you as a little bit of a review. Here's problem 1. My hand, when I use the dot camera, there's a little bit of a delay, but you should be able to see the writing and listen to me as I narrate my way through. All right, 2,564 divided by 8. So we put the big number in the house. We've got the 8 outside, and we start asking questions. Does 8 go into 2? No, it doesn't. Does 8 go into 25? Yes. It goes in there 3 times. I like to put a little time sign there. 8 times 3, it's 24. When I subtract away, I've got a remainder of 1. Okay? Now, does 8 go into 1? No, it doesn't. I can bring down a 6. Does 8 go into the 16? Yes, it goes into 16. 2 times. 2 times 8 is 16. I'll subtract away and I've got 0. Here are some important questions. Keep finishing it out. Does 8 go into 0? No, it doesn't. Let's bring down this 4 here. How many times does 8 go into 4? Well, it goes in there 0 times. You've got a remainder. It's just, it won't fit in there. So what you end up with is you end up with 320 with a remainder of 4. But when I look over here with my answers, none of those answers look anything like that. So let me think about that remainder. That remainder really means 320 and 4 out of 8. Correct? 4/8, 4 parts left out of 8. Or I could rewrite that as 320 and 1/2. I could simplify it to a fraction, but I still don't see that over here. But when I look down here, I do see a decimal that is the same as 1/2. So your answer is 320.5. What they did there is a little trick there. They replaced the fraction 1/2 with the decimal. Okay, down here, which number has 5 in the 10,000ths place? And I did a little drawing ahead of time on this one for you. A lot of kids think that the balancing point is the decimal, but everything revolves around number 1 right here. This is the tens, this is the tenths. This is the hundreds, this is the hundredths. This is the thousand, this is the thousandths. This is the 10,000ths. This is the 10,000s, this is the 10,000ths. Over on this side, a lot of spitting going on, but you know what I'm saying. So tens, hundreds, thousands, 10,000ths. This is exactly what I do. So we're looking for which number has 5 in the 10,000ths place. So I'm looking for the 1, 2, 3. I'm looking for the 4th decimal deep here. Let me see. The 5 here, this is 1, 2, 3, 4. That's in the 5th spot. That's not it. 1, 2, 3, 4. This one right here looks like it's 5 in the 10,000ths. This one here, nope. That's in the 3rd spot. That would be in the thousandths. This one would be in the tens. So these ones here don't appear to be correct. Let me just double check. Tens, hundreds, thousands, 10,000ths. 10,000ths. So there we go. There's my answer. B. All right. Turn this guy over. Okay. Johann's race was 45. Race time was 45.03 seconds. Kyle's race time was 0.1 second less than Johann's time. What was Kyle's? So this is Johann's. Kyle's is going to be this much less. So we just set those up and we're looking for a difference here. So we're going to subtract. So 45.03 minus 0.1. Now I don't like that, so I put a placeholder in there, 0.10. It helps me out. I've got my decimals lined up here. That's what's important when adding or subtracting decimals. So 3 minus 0, that is 3. 0 minus 1, I can't do that, so I'm going to go over here and I'm going to trade. That becomes a 4. Now I've got 10 here. 10 minus 1 is 9. There's my decimal point. And of course I got 4 minus 0 is 4. 4 minus 0 again is 4. So I have 44.93 seconds. Let me just double check. What was Kyle's race time? Yeah, Kyle was minus 0.1 or a tenth of a second, so it's 44.93. Okay? The next one, what is this number rounded to the nearest thousandth? Wow. So we've got to look here. We got 0.045831 to the nearest thousandths. Well, if you remember, what I always tell you to do is go to whatever they say. They said go to the thousandths. So if you remember, this is 10 hundredths, thousandths. We put an arrow over the top. We look next door. Is there enough there to bump this guy up? Well, it's got to be 5, 6, 7, 8, or 9, and that ain't enough, folks. There's our number right there. These all just become zeros. There's your rounded number. Okay. Number 5. Here we just got to add. Again, these are not calculator targets here, so we just need to go ahead and line up our decimals. 4.45.908 plus 3.26, and again, I'm going to add that 0 on there just so everything lines up nicely, and of course we're adding. 8 plus 0 is 8, 0 plus 6 is 6, 9 plus 2 is 11. My decimal in there. So 1 plus 5 is 6, plus 3 is 9, and we've got 49.168. Matches answer B. Don't forget, got to line up the decimals when you add or subtract, and then put zeros in there. This is probably the toughest problem on the page or in the packet. Kids struggled with it. A fraction model is shown. Well, let's see what we've got here. What is represented by the model? Well, I've got these two guys here colored in up top. So if I look at these fraction bars, what I have up top here in this first one is 2/3. That's this one here. I've got 2 out of 3 colored in. Then it looks like I've got 1, 2, 3. 1, 2, 3 out of 4, 5, 6, 7. So I got 3 out of 8 here. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I've got 24 as my denominator here. And I've got 1, 2, 3, 4, 5, 6, 7 of them colored in, 7/24. So I'm trying to figure out what's going on here. But first of all, I had to identify what were the fractions in the strip. So does it look like 2/1 minus 3/5? No, there's no 2 1s or 3/5 here. I did have 2/3 up top, 2/3, and if I take away the 3/8 here, I end up with the 7/24. They don't have that, but right now, this is the one I'm thinking it's going to be. 2/3 minus 1/5. No, this is 3/8. There's no 1/5 here, so it can't be that. 3/8 minus 7/24. Well, here's the 3/8, but I'm not really taking the 7/24 from it. I've got that slid over, so I see the problem. 2/3 minus 3/8 leaves me this much left over because I used this much of it, and this much is left. All right, so this is the correct answer right here. Tough problem. Start with the answers when you get on those and work backwards if you can't figure out what they're doing. All right, yesterday Jamal read 17 pages in his book. Today he read more pages than he read yesterday. Which inequality shows P, the number of pages Jamal could have read today? Well, he read 17 yesterday, and today he read more than that. Okay, he read more pages than he read yesterday. Which inequality shows P, the number of pages Jamal could have read today? So P is going to be today, which is more than 17, right? Because that's what he read yesterday. We know it's going to be more than that. All right. So this is P is less than 17. It can't be that one because he read more. This is P is less than or equal to. That's what that means, less than or equal to. Well, he read more than 17, so it can't be less than or equal to. P is greater than 17. Well, that's what I said. Over here is more than 17. So right now, that's my best choice. P is greater than or equal to 17. And again, it's not this one because he read more than 17. Not equal to 17, but he read more. So This one's crossed out. The only answer that makes sense here is P is greater than 17. That's what it said right here. He read more than 17. Okay, how many edges does a hexagonal prism have? Well, I drew one out here. It's not pretty, but let's see. We've got 1, 2, 3, 4, 5, 6. A hexagon has 6. So I've got 6 on this end. And of course, in the end, we can't see I have 6. So there I'm at 12. Whoops, I'm going to write that over there so you can see it. I've got 12 just on the two bases. But I also have edges here. Remember, an edge is where two faces meet. So I've got 6 faces, rectangular faces, along with those two bases. So I have to add 6 more in. 1, 2, 3, 4, 5, 6 there as well. Or you can think of it as one coming off of each of these vertexes. So I got a total of 18. All right. This is a tough problem too. But now we are into our calculator segment. So I'm going to get my calculator out and have that ready to roll here. Hopefully you'll be able to read that. All right. So we've got 500 pieces of paper that Jan has. She prints as many copies as possible of a 16-page report. So what she's going to do is she's going to take that 500 and she's going to divide it by 16. So let me do that real quick. So 500 divided by 16 pages for each report. It looks like she could write equals 31.25 reports. So she can't print out 32 of them, but she can print out 31.25 or 30 1/4. So it's 31 total reports. Now let's get back to that question. She prints as many copies as possible of the 16-page report. How many pieces of paper are left? Okay, well, if she made 31 copies of it times the 16, she used 496 pages used. Now she had 500, so a simple addition shows us that there are going to be 4 pages left over that she can't use. Remember that 31.25? That was a quarter of the report. So I think there'll be something like this on the test where you have to do some multiplication or division and then some adding or subtracting. So that one is A is the correct answer there. All right, this one here can be kind of tricky too. I'm going to put that up there for now. Bookcase has 4 shelves. The bottom shelf has 10 books in it. Each of the other shelves has 5 more books than the shelf below it. How many books are in the bookcase? Okay, so if this one has 10, this has 10 plus 5, which is 15. This one will have 15 plus 5, which is going to be 20. And this one will have 20 plus 5, which is 25. So I want to go right over here and circle 25, right? Wrong. Always go back and read the question, because what they're actually asking you here for is how many are on the bookcase. How many are in the bookcase? So you've got 10 plus 15 plus 20 plus 25. If you pop all of those in, 20 plus 25, that would be 45. These 5 would make 50. Here's 60, and a total of 70. You could do it in the calculator, but there's your correct answer, 70. All right. Next problem. I think I got time for maybe one more before I run out of tape here. 5 points shown on the number line. Between which 2 points is 7/16 located? First thing, we have to determine the interval. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we start at 0, and here's 1. So each of these are tenths, or 0.1, 0.2, 0.3. And then I like to find the halfway point. Well, the halfway point is going to be at 0.5, or 0.5. So here's my halfway point right here. That's 0.5. So I have to figure out where 7/16 is located. I always like to have a couple of landmarks there. So let's go ahead and just take 7 divided by 16, and that is going to be 43.75. So that's going to be somewhere right in here, in between 0.4, and 0.5. So that's going to be in between K and L. In between K and L. Okay? I make it look simple, don't I? Yeah. Just some real simple things. Determine the